Hi, this is Terry Iverson from Iverson & Company, Champion Now, with CNC Rocks Virtual Manufacturing Camp. Today we're going to talk about robotics and automation as it pertains to manufacturing in this country. Some people over the years have indicated that automation will take jobs away in this country. The reality of it is that while some jobs will be taken away, other jobs will be created. Let me explain. So we used to have an operator that would open the door, put in a part, close the work holding device, close the door, and hit cycle start. In today's world, we have robotics or robotic arms. I'm going to cycle start the robot just to give you an idea what it looks like when it loads. It's going at about 10% of the speed it would normally go for visual purposes. So what we have is the gripper will go in, and we have just an acrylic part being held in a collet in the spindle, and so it's going to take the part out and then go and place it on the pallet as a completed part, and then it'll pick up a blank that's non-machined or is not machined, and then bring it over, go through the opening in the trap door, and then it'll load the second part. After it loads the second part, it'll then close the work holding device, come out of the opening in the door, close the hatch, so to speak, and then you can begin your machining. So consequently, just when someone says automation is taking away jobs, the true answer and the reality of it is taking away jobs, but it's creating more jobs. For example, you have to have someone to program the robot, someone to repair the robot. You have to still have someone program the machine and set the machine up. And then you have a whole litany of people that inspect the finished parts. So in order to compete globally in the manufacturing economy here in the United States, we need to embrace automation, and in doing so, it opens the door to all sorts of higher skilled jobs, and that's what we need new workers for and new young people to embrace, is those newer high skilled jobs in manufacturing. We talk about automation, and automation can be defined many ways. Earlier I talked about automation being a robot loading a CNC lathe. So that is one type of automation. But the other type of automation is something as simple as a bar feed. Remember, I keep talking about a lot of the terms in our industry are very literal. I talked about a bar feed feeding a piece of bar stock. So this is a piece of brass about 1 inch round. And so there's a tube that allows me to hydraulically support this bar within a tube of a certain size. Usually they have different sizes for different diameters. So in this particular case, it's 1 inch. So this style of bar feed is called a hydrodynamic bar feed. And what that means is hydraulically, as the bar spins, because it's inside of a spindle, here's the back of the CNC lathe, and this is going to feed up through the collet in the spindle. And as the collet grips it, the spindle is going to spin it, and so it needs to be supported outside of the machine. That's what the bar feed does. It supports and feeds the bar. The hydrodynamic capability or concept is that as it spins and as the tube spins or the oil spins, that centrifugal force will force it to the outside and allow for it to be supported around the bar itself. And so there's a hydraulic pump that circulates the hydraulic fluid within the bar feed and within the tube. So that is one style of automation, whereas prior to production machines, prior to automatic machines, prior to CNC machines, computer numerical controlled machines, manual operators would have bars that they would initially manually advance. Then they would have gravity-fed stands that would support on the outside of the spindle. They didn't have hydraulics. Then they went to pneumatically, having a pusher. Same thing with a hydrodynamic bar feed. You have a pusher. And so you have pressure, either pneumatically or hydraulically, in this case hydraulically, that goes behind the pusher and pushes, in addition to holding the bar and supporting the bar along the length of the tube, it also, the piston builds up hydraulic pressure behind the piston, and the piston pushes it forward and advances the bar into the spindle, into the collet, and into the envelope of the working area. Now think about a piston. The piston has to seat on this, and usually the piston has a cone of sorts, and so it's usually a taper. And as you can see, if you look, you have a very sharp edge on the end of a piece of bar. So if you had a cone on the actual pusher and you had a straight edge, that would cut into the pusher, and all those filings and material would end up in your hydraulic system. That's a bad thing. So what you want to do on a bar feed, on a bar, for a bar feed, is you want to put a chamfer on the back side. So usually there'll be, probably like a 60-degree chamfer on the back side of the bar so that that taper matches the pusher. And once it matches, not only does it not cut into the actual pusher itself, but it actually is a mate, so it centers the back end of the bar. So now you got the back end of the bar centered because the taper of the pusher and the taper on the end of the bar match. You have the hydrodynamic fluid, the hydraulic fluid, over the course of the length of the bar. And then you have the collet up at the end where the spindle is. There's one more concept I need to explain. Inside the spindle, rather than having it totally not supported, they'll have what they call a spindle liner. Once again, a very literal term. It's a liner that's inside the spindle. So you'll machine, usually it's Teflon or plastic or a different type of material that's very easy, and it'll wear before the spindle wears, so you don't do damage to the spindle, and it won't damage the bar stock either. So you'll either have a solid liner that you'll insert into the spindle, or you'll have spacers and then plastic bushings that you'll machine just over the diameter of the bar, but it also has to allow the pusher to go through. So you got to take into account what the diameter of your pusher is and what the diameter of your bar is before you machine the actual bushing in the spindle liner. Usually you'll have 2 or 3 bushings inside and then 2 spacers in between the 3 bushings. So that's the functionality of a spindle liner. So that's one other thing that I'll talk about in terms of bar feeds is they have single tube bar feeds. Then they have also something called magazine bar feeds. A magazine bar feed will have the bars stacked up so that if you're running longer jobs, this is even more automation when you have a magazine bar feed. Once this bar finishes, the pusher will push it out and you'll have what you call a bar end, which will be disposed of either down below in a catcher or out the front of the machine into the chip pan, where many times the chip conveyor will take it out. Then another bar will gravity fed into its place, into a location, into a V, and then the pusher will retract and then come up to the end of the new bar, and then it'll come to center, and then the pusher will push it, advance it until such a time that it's in the collet, and the collet will close. So that's called a magazine bar feed. Bar feeds come in 6-foot lengths, 12-foot lengths. Magazine bar feeds come in, some can only feed, there's a term I call bar stuffers. It's a magazine bar feed, but it only stuffs the bar length into the spindle. It doesn't support, it has no means of supporting like this bar feed or a hydrodynamic bar feed. So what you'll do is you'll have whatever your length of your spindle is, and this is a good example of the length of a short lathe, like some of the lathes I've shown you. So you'll have these bars stacked up, and it'll stuff it totally within the spindle liner and the spindle, and then advance it from there. So I call those bar stuffers, but they're still a type of magazine bar feed. And those bar feeds are much shorter and will handle lengths, the length of whatever given lathe spindle each machine is. So it's very specific in terms of length to a given machine tool. One thing that I should mention about a hydrodynamic bar feed is when you finish the bar, it's not a magazine bar feed, so it doesn't have multiple bars. This particular one, there is a single tube hydrodynamic bar feed and a multi-tube. This multi-tube is in a linear movement. Then there's others that are like a Gatling gun, to make an analogy, like a Gatling gun machine gun. where you rotate to the tube that's appropriate for the diameter of the bar. But when the bar is done and the bar end is out of the bar feed, this is in such a way so that you can swing this out so that your bar, however long it is, can clear the machine tool. So this will extend, and when you move this across, this will allow your bar to clear the edge of the machine so you can load it from the front. And then once it's all the way into the internal workings of the tube, then you can push this back to center line. And then once it's back to center line, then you can lock it down, and then it's ready to actuate. Automation comes in many forms. We talked about robotic loading. We talked about bar feeds. Now we're going to talk about a term called one and done. Manufacturing, going back in high volumes, used to be pieced out in departments and different processes. So what you would do when you were manufacturing high volume is you'd have the lathe department and you do all the lathe work. Then you would have the secondary department and you would maybe turn a part around and do the back side on another lathe. Then you would take it over to the milling department and you might do some milling work on the parts, and you would have different lots and different batch manufacturing basically. So most shops were set up where they had the lathe department, the secondary department, and the milling department. As volumes came down, you can't ship your product if you're doing all the lathe work in the lathe department until it goes to lathe, secondary, and then milling. And then if you have to grind it, ultimately grinding. So as the quantities came down, manufacturing decided to do more in one machine. That way, every time you got a part off, whatever quantity you had, you could ship to your customer. Once you put a bar feed, or you can load a slug with a person loading it or a robot loading it, you'll have the part on the main spindle where you do all the main spindle work. This is called a sub spindle. It's a sub to the main. So once again, pretty literal translation. So what will happen is you'll grab your turned feature and grip it and then cut off the part, or if it's too big to cut off, you'll just merely grab it and bring it across, and it'll be in your sub spindle, and then you'll machine the back side. So what would normally go to a secondary department now can be the secondary department is your sub spindle on the same machine that you did the primary operation. So you can do a back face, you can do a counter bore or a back bore, a thread, detail on the radius or on an angle. And so now you have a first and second operation done. It doesn't have to go to secondary, and it may not have to go to the third department, which is the milling department. On this turret, where your tools reside on a lathe, is called the turret. And on the turret, you have a feature called live tooling. Now once again, we're going to talk about literal translation. Live tooling means the tool is live, so it rotates. So you can do a milling operation, a drilling operation, a tapping operation. So if there was a flat on this particular component, if it was on this side and there was a flat, I could mill a flat on here, I could drill a cross hole here, I could tap a cross hole. I could put a hex on the face, on the diameter. So having live tooling allows an additional secondary operation. Instead of the primary, secondary, and then over to the milling operation, you forego all of that, and it renders the term one and done. It comes out of the machine and it's done, goes to inspection. Many times the inspection's done right on the shop floor, right at the machine. These machines become so automated. Remember, automation's a good thing. that the person tending the machine, instead of loading the machine, is now loading the bar in the bar feed, and is also checking the part or parts coming off of multiple machines. So the more someone in the shop, the more versatile they are, the more valuable they are to their employer, the more valuable they are to themselves. So there's a lot of inspection elements when a CNC programmer, a CNC operator, lead man, what have you, is running a CNC machine, because now that part is coming off the machine almost completely done. Now you have to check it, inspect it, quantify that it's a good part, prep it for shipment, and then ship it. So this segment is to explain that automation comes in many different shapes and forms, and it's not just a robot. And the more automation that we can employ, and the more employees and the people, young people of this country can get excited about computer technology, the more competitive we can be, the more product can be made in the US, and the more people can be employed in the US for manufacturing.